Do you want to know about Knime analytics software and how we can implement certain applications or algorithms to check data's accuracy with a live dataset? Hey everyone, we are from ALM Kolkata with stream Business Analytics and Data Science, and we are going to look into the Knime software, and we will look into different measures and algorithms to check a data's accuracy. So let's get started. First, we need to know what and why we use Knime Analytics. So Knime Analytics is an open source software used for data and open software for data analytics and integration for analysis, reporting and integration. It provides an environment for data scientists that they can practice or visualize results. So first we will go to the Knime Analytics software. Firstly, we will check the CSV reader. In Knime Analytics, we work like it is a workflow and we drag and drop nodes. Nodes can be searched here. You can search any nodes from here and you can drag and drop it here and work and connect flows from any one node to another. So firstly, we will use CSV reader. CSV reader is used to see a file's data and structure it. Then we click the data and check how many inputs of 0 and 1 are there. After that, we use the node histogram. In histogram, we check how many number of ones and zeros are there in the data. After that, we use missing values to check how many missing values are there in the data. If there are missing values, the software will automatically detect it and put it in the following table. Following number to string. We use number to string to put the numeric values of a data to a string value. Inside of number to string, we will include purchased and exclude user ID, age and estimated salary. After that, continuing, we will use partitioning. Partitioning is used to divide two table in two different segments, where this one is the first partitioning and this is the second partition. Following, we will use SMOTE analysis. In SMOTE analysis, the software itself auto-regresses few artificially made values in the table. After this, we will use ML algorithms, which will be further explained by my fellow team members.
Thank you so much, and I will be discussing about the SPM model. In SPM model, we have SPM learner. SPM stands for support vector machine, a supervised learning machine that is basically used for the classification by finding the best hyperplane, and it also chooses the best values. And after that, we have SPM predictor. So SPM predictors is basically used for that testing the data, and after that we have connected the scorer. In this scorer we can see that the zeros value we have selected the zero values is non purchased and one is for purchased, and in this scorer we can see that there is no one value, so it's not showing the one values. And the overall accuracy is 63.7%, and it's enabled is failed to detect the one class. And after that we can see the ROC curve. In this ROC curve, as we have we have seen that the one is not detected by the SPM learner and
Thank you, Rajat. In this Knime project, we trained a classification model using the decision tree learner. The model was trained on data from the partitioning node, which split the datashet into training and testing sets. Before training, we handled missing values, converted data types, and applied SMOTE to balance the data. The trained model was then used to make predictions with the decision tree predictor. These predictions were evaluated by the scorer node, which provided results like accuracy and a confusion matrix. The confusion matrix showed 47 true positives, 25 true negatives, 4 false positives, and 4 false negatives. With an overall accuracy of 86.2%, the model correctly predicted most cases, which means it was right about 86 out of every 100 predictions. Finally, the ROC curve of the decision tree also showed a sharp rise toward the top left, indicating a high true positive rate and a low false positive rate. This suggests that the model is accurate and performs well. So the next part will be explained by my fellow friend Komal.
Thank you, Anika. So we will go ahead the next email learning method, random forest learner. We bring the random forest learner, and random forest learner is basically used to train the model by creating multiple decision trees on different parts of the data and combining them to improve accuracy and reducing overfitting. Then we will connect to the random forest learner to the SMOTE, and there will not any changes in this, so only apply, and then we will bring the random forest predictor. Random forest predictor is used to make prediction using the trained random forest model by aggregating the outputs of all the decision trees, and then we will connect it to the random forest model and partitioning. And then we will bring the scorer is we looking at the confusion matrix. We can see that the true positive and true negative values are significantly higher than the false positive and false negative values, which indicates a good model performance. And then we looking at the model accuracy, its value is see that the model accuracy stands at 0.912. It's meaning that during testing, 91% of the prediction matched the actual outputs. Then furthermore, the ROC curve shows that the prediction score is close to 1, especially around 0.967. It suggested strong predictive power and high accuracy of the model. And the next ML algorithm is continuing by my fellow member Deepsika.
Thank you, Kamal. Now let's look at the Knime-based learner. It is used to train the model based on probability. We then connect it to the Knime-based predictor to make prediction on test data. This helps us check how well the model can classify new data. After making predictions, we connect the model to the scorer node. The scorer compares the predicted results with the actual values. And this is the confusion matrix. It shows that the model correctly predicted 41 cases of class 0 and 22 cases of class 1. It made some mistakes by predicting 10 class 0 as class 1 and class as 1 as class 0. Overall, it gives more correct results than wrong ones. In the accuracy statistics, we had 41 true positives and 22 true negatives. It made 10 false negatives and 7 false negatives. Overall, the model achieves 0.787 accuracy, correctly predicting about 8 out of 10 cases. And this is ROC graphs to Knime-based models' ability to separate classes. The blue line above the diagonal means it performs better than random. With an AUC of 0.879, the model shows strong classification performance. So the discussion will now taken over by Sudisha.
Next, we take the training data from SMOTE to the PNN learner, where we train in a probabilistic neural network PNN based on the DDA, that is dynamic decay adjustment method, on label data using constructive training of probabilistic neural networks as the underlying algorithm. Then we connect this model to the model input of the PNN predictor and also take the testing data from the partitioning node. Next, we feed the output of this prediction to the scorer, and also we feed this output to the ROC curve. In the scorer, we can see that we have 18 true positives for 1 with F measure 0.643 and accuracy 0.75, which is not bad, but not that great. And in ROC curve 2, we see area under the curve value is 0.783 for the predicted value of the target column purchase as 1, which is again a positive good value. Once we have taken all these predictions into account, we then feed these outputs to 4 concatenate nodes. In the first concatenate node, we concatenate the accuracy statistics for the first 2 models, and we append the suffix with the model name for easier detection in the Excel output that we'll be showing you next. Then in second one, we take the input from the first concatenate and the second of the second scorer. So after generating all these concatenated nodes, we then add the Excel writer where we are saving these and then comparing all the predictions for all the models. We can see that the random forest gives the best combination of F measure, accuracy, and ROC amongst all the models we have applied. So we can conclude that we will take these values of random forest into consideration for further prediction and forecasting. Thanks a lot for watching this video and hope this helps in building a codeless, efficient project in Knime. Thank you.